Today I am going to explain cell sorted, which is the important sorting algorithm in data structure and algorithms. Cell sorted is an improved version of insertion sort. It was introduced by Murat Cell. The main idea behind the cell sorter is the reduce the number of shift and comparison required in the insertion sort. Explanation with the array is large. Its presentation it will explain. First one is what cell sort is, why we need it and how it works, and gets its sequence concept, step by step example, advantage and disadvantage, time and space complexity. What is cell sorting? Cell sort is a comparison based sorted algorithm. It's sort element by comparing elements that are far apart, then gradually reduce the distance between them. Finally, performs a normal insertion sort because element moving faster toward the correct position. Cell sort is much more effective than standard insertion sort for large datasets. Second one, why do we need cell sorted? Insertion sort works well for small arrays, but becomes slowly for large array because instance elements move only one position at the time. In large element at the end require many shifts. Cell sort solving the problem by allowing element to jump multiple positions, reducing total number of shifts, making the array nearly sorted before finally insertion sort. Core idea of cell sort. The key concept of cell sort is a gap inside of comparison advancing elements. Cell sort's main choice is gap value. Sort elements that are gap position apart. Reduce the gap step by step. Continuous till the gap equals 1. When the gap equals 1, the algorithm behaves exactly like insertion sort, but by then the array is almost sorted. Gap sequence concept. A gap sequence concept defines how the gap value changes. Common gap sequence example. Gaps equal n to 2 continuous until gap 1. Example for n equal 8. First gap is a 4, second gap is 2, and third gap last one is a 1. This gradually reduces it's the reason cell sort works better. How to step by step explain. Let's understand the cell sorted using an example. So 8 number of array. Let's calculate intel gap n equal 8 gap. It's a 8 divide 2. It's a 4. Gap 4. It's a similar idea. We compare element 4 position birth. Compare index 0 and 4. It's a 23 and 34. No changes. Compare index 1 and 5. It's a 12 and 54. No changes. Compare index 2 and 6. It's a 1 and 2. No changes. Array because gets 2. Now we compare element 2 position but after sorting substitutes. It's a 1, 3, 2, 8, 23, 12, 34, 54. It's a 8 number of gets. Gets 1. Now cell sort performance normal insertion zone. Final sort array is example. How cell sort works internally. Internally, cell sorts divide the array into subdates on gaps. Clean insertion sort on each sublist regionally reduces gaps ends with a full sort array. This approach simplification improves shortens time and space complexity. Time complexity. So the time complexity best case it's a O. N log and average case depend on the gap sequence. Worst case O. Practice cell sort performance much better than insertion sort. Space completely 0 1. It's a in place sort algorithm. Advantage cell sort. Its first one is faster than insertion sort. Work well for medium-sized array. Third one is in-place algorithm, and last one is to implement imitation of set. So its first one not stable. Performance depend on the gap sequence, and last one slow than advanced sort like quick sort and merge sort. Consolation is final to consolation cell sort and optimized version of insertion sort. It's use concept of gap-based comparison. It's reduce the number of shift. It's efficiency for medium-sized data. Cell sort play an important role in the understand how algorithm optimize works. Thank you for listening.